Let's take a look. Okay, so they're telling us about correct variable names. And when they're talking about variable names, they're talking about, like, you know, when we do stuff like, you know, let digit be assigned to value of 5, like that kind of stuff, you know? So the variable name would be this thing. And you've probably noticed, like, we could say digit 1, we could call it something like that, and that's no problem. We could even put, like, an underscore, and it's not going to have a problem with that. We could even put the underscore as the first character, and although that kind of means something special to some readers, it's still not going to have a problem with it. Now, if I put the 1 in front, notice all the colors change. It's interpreting this totally differently, and it's like, what are you talking about? You can't do that. So you can't start a variable name with a number. But you could start it with a word character, or like an underscore or something like that. So all of that would be fine. Okay, so how are we going to do this one? Well, I mean, okay, here's what I'm going to say about this one. I don't want to reveal too much. I don't want to give any spoilies here, but this is a situation where we're talking about a string, right? We're talking about checking some characteristics about a string, specifically that it doesn't start with a number, but that, you know, it starts with some alphabetical character or an underscore, and then that everything after it is either like alphanumeric or an underscore. Okay, so basically if we want to check a property about a string, probably we'll use a regular expression. I mean, it's usually the most efficient way to do it. But I do want to say something about this, because regular expressions used to be something that really stressed me out. Something that really, like, it was just kind of anxiety inducing, you know, like just the idea of thinking about regular expressions, it kind of freaked me out. If we take a look back, where did we use one before? We used a regular expression on one of these things. Yeah, this one. It's like, look at this, you know, comparing this thing here to what we had down here. Like, it's replacing all of that code with just this one line. But does it make a lot of sense to look at? I mean, it looks intimidating. It looks gross. It looks like a whole pile of garbage. So basically, I was pretty resistant about regular expressions for a long time. And I even, like, you know, I went to Eloquent JavaScript. I read the regular expressions chapter, and like I had at least somewhat of an understanding of what they're all about, but I still didn't feel comfortable with them. I still didn't like looking at something like this, and especially trying to like decode what this was saying. The thing about regular expressions is if you miss even one character, you know, like let's say you disregard a backslash, that fundamentally changes the meaning of it. I mean, it will completely rock this regular expression's whole world. Every character counts, and every character is generally saying a lot in a regular expression. So because of that, they almost seem like kind of fragile, kind of risky to use, but I encourage you to use them. I think they're a good thing. They're a tool that are available to us, and they're going to help us out. So especially in a case like this, we're going to see how much they help us out here. The reason we're going to see that is we're going to start by not using them. So we're going to start without regular expressions and see how it's going to eventually compare to the method we use for if we do have regular expressions. And that's all we're going to do for this one. So we're just going to do two possible algorithms, one without regular expressions, one with regular expressions, and that's it. Okay, so my goal here is, number one, to help you see how much benefit we can get from regular expressions, and number two, to hopefully help you overcome any kind of anxiety you're feeling about regular expressions, because I know it was really tough for me to actually break into them and feel okay about using them. All right, so are we ready to get started? Yeah, I think so. So the first thing I want to do is write a function here that's just going to check if something's a digit. So it's just going to take a character, and it's just going to return true if it's a digit and false if it's not. So we could use like character codes and stuff like that here, but I'm just going to do it sort of the easy mode way and just do this. If the character is between the 0 string and the 9 string inclusively, then we're good. Okay, and then is letter. This is going to be another one, and again, it's going to take a character. And there are a couple ways I could do this one. I could say something like return A is less than or equal, less than or equal to character, and character is less than or equal to Z. Yeah, just Z. Okay, I could do this, but then the problem is that's just for lowercase. So I could say, all right, well, put all of that in parentheses and then put a big old or, and then we'll basically do the same thing, except we'll do these in uppercase now. Okay, so that's a way that we could check if something's a letter, and we can try running these things. So like return, is letter, and then P. There we go. So is this a letter? It should be. So yeah, we're getting true for that. And is it a digit? No, it's not a digit. Okay, and you might be looking at this and saying, well, I don't know about this is letter thing because, you know, we could say something like, give it a full word, right? And ask it, is that a letter? And I guess it is saying false. Okay, I was worried that just because of the lexicographic comparison here, I was worried that a full word was actually going to work there. So, okay, that's good to see that it's not. What if I give it like an underscore? Is that going to work? No, it's not. Okay, great. So these are working. I'm going to make a slight modification to is letter. I'm going to say lowercase character is going to be assigned the value of character dot to lowercase. Okay, so that's basically just going to convert it to the lowercase version of whatever it was. Let's throw a little let on there so that it knows what we're talking about. And I'm just going to put these in here. And now I don't have to say the or, because if it was lowercase already, it's going to continue being lowercase. If it was not lowercase, then it's going to become lowercase. And so this is going to be a fine comparison. So now, oh, you know, I just realized something. Is letter P. Was I doing is digit before? Oh, too lowercase. What did I do wrong? Was it a case sensitivity issue? Isn't that ironic? It was a case sensitivity issue. Okay, so this is telling me true. Yeah, this is a letter, but what if I made it uppercase? Is it still a letter? Is it still working? Is it comparing it to this range accurately by converting it to a lowercase first and then comparing it to lowercase a and lowercase z? Yeah, it's still working. Now, I want to check that thing I was looking at before, because I think I might have been using is digit when I meant to be using is letter. Yeah, okay, so it is saying true. Okay, so here's the thing. If we want to be airtight about this, if we really wanted to be properly providing an algorithm that checks if something's a letter, yeah, technically there should be something that says, like, if character.length is greater than 1, return false. But that's not really something we need to worry about here. I mean, if character.length is greater than 1, return false. I mean, the reason I'm checking if this is a letter with an input of character is because I'm planning on only putting something of length 1 into this anyway. So yeah, that would be something to do if we wanted this to be like multi-purpose, if we wanted this to be usable outside of this code, but you know, it's fine in here just to do it like this, I think. So okay, let's go back down here. So we're outside of these functions now, and what we want to do is we want to say, well, if the first character, so if name at 0 is, well, basically if it's not a letter, and it's not, well, what else could it possibly be? It couldn't be a digit since it's the first one, but we'll say it's not an underscore, okay? So if the first character is not a letter and not an underscore, then we're gonna return false. Run. There we go, return false, okay. And if we make it past that, then I guess we'll run a loop on this. We'll say for let I is assigned the value of 1. Notice we're starting at 1 because we've already covered the case for 0 above, just in the previous line over here. We looked at the first character, and the reason we did that separately is because the comparison is going to be a little bit different. We're saying, okay, and before we go any further, we'll just say let character be assigned the value of name at I. And then we'll say if not is letter, character. So if the character is not a letter and it's not a digit and it's not just an underscore. Well, under that circumstance, also return false, just like we did above. And if it makes it through all of that without getting any of those falses, then I guess it must be true. Okay, great. So that's what we were looking for. That's a working algorithm now. Awesome. Okay, so there are probably some changes we can make here if we really wanted to, but I think it's probably pretty good. Seems pretty good. What do you think? Pretty good? Yeah, pretty good. Okay, but keep in mind, the reason I wanted to do this, the main reason I wanted to start with this thing that used no regular expressions is because, partly at least, we want to see how much of a benefit we can get from using a regular expression on this thing. Okay, so basically what we want to do for our regular expression, again, we're going to do some regular expression dot test with an argument of name, and that's going to be it. And this is not meant to be a comment, it's just meant to be a regex. Okay, so I guess we should probably test this out. Maybe we'll go over here again. Oh, it's still got our stuff from the IPv4 one. All right, so let's see. What should we accept? Something like, okay, good variable. We'll say also good. And then something like not good and too bad. And then maybe one that starts with an underscore and has like some funny letters and stuff in it. Okay, so great. Which ones of these do we want to accept? All right, well, basically we want to say start with something that's just a word character, and then after that you can be, well, actually, before we go any further, something to notice is word characters can be uppercase or lowercase letters. They could also be underscores, and they could also be digits. We don't want a digit for the first one, for our first character. So really we shouldn't be using the W. We should be using something like an A to Z or something like that, right? From uppercase A to lowercase Z. The thing about this is also matching a lot of things. Notice it's not matching the 2, so that's good. That's what we're looking for. But it's still matching the underscore. So maybe that's good, actually. Maybe we'll use that to our advantage. And then basically after that, we can have any word character. So we'll just do \W. And I'm going to put a plus on that. So that's basically saying as many of those as you want. You know, one or more. And in fact, maybe I'll put a asterisk so that it's like 0 or more, because a variable could be like just A, right? That's perfectly fine. Okay, so now the too bad is not matching, the not good. Well, yeah, it looks like it's kind of not matching. Technically, that's because we need to put an end of line thing over here and then a beginning of line thing over there. And now, since there are multiple lines here, we're gonna have to look at these individually. So we could say, all right, is good variable working? Yeah, good variable works. What about the too bad one we had before? No, that's not working. What about something like cool, dude? Something like that, is that working? No, it's not, because these square brackets here are not word characters. Okay, so then the problem is this. This is working. So even though all these other ones after the first character were only allowed word characters, this is being accepted by our A to Z here. So that seems a bit bad. And yeah, it is. The reason that's working is because we're saying from capital A to lowercase z. So from 65 to 122 on the ASCII table. That includes square brackets, backslashes, carets, underscores. So it's a side effect that the underscore was working in here. That's just a coincidence. What we really want is, we'll be specific, we want capital A to capital Z, we want lowercase a to lowercase z, and we want the underscore. Okay, so this is not good, but if we made it something like that, dude. Okay, so that's great. We'll take this and copy it over to this, because that is our regular expression. Does it work? Wow, look at that. And yeah, why'd they put those in there, right? I mean, wouldn't we have expected it just to go from the uppercase alphabet to the lowercase alphabet? No, you got backticks and underscores and all kinds of other fun stuff in there. Okay, so look at this. This passed all the tests. Passed all the visible tests anyway. Does it pass all the hidden tests? Let's find out. Let's try submitting this, and we'll see if it works. Okay, and I guess we technically did not check the other one for all the hidden tests, but I'm pretty confident that it would work. The main thing is this. Look, this is like big savings, you know? Look at how much we didn't have to do by just doing it this way. So look, knowing regular expressions, if you have the patience and the perseverance to really pick it up and to stick with it, I recommend it, because it's like having cheat codes. You know, it's like having a superpower. Like, it basically just gets you right to the end here in so many cases. So we're probably going to see more like that in the future, but for now, I think that's going to be it for this one. I mean, you've got my solution over here, 5,129. You can check that out if you want, but the main thing is just a regular expression can really, really save us some headaches, save us some time. So I do recommend them. Let me know if you have any questions, comments, or concerns. And I guess for now, yeah, I guess we'll move on to the next one. Yeah, let's move on to the next one. Okay, great.